Greetings learners. In one of the previous lessons we discussed one-dimensional arrays. In the lesson it was argued that storing and manipulating large amounts of data using regular variables is very cumbersome. On the other hand, arrays offers the ease of dealing with a single array type variable along with the capability of storing large amounts of data. In this lesson we will understand two-dimensional arrays, which can be considered to be an extension of one-dimensional arrays. Understanding of two-dimensional arrays requires a sound grip over the concepts covered in the lessons on pointers and one-dimensional arrays. It is advisable to quickly revise those lessons before starting this one. This lesson begins with explaining the context of using two-dimensional arrays, followed by a quick discussion on how they can be visualized. Declaration and initialization of two-dimensional arrays is taken up next. The lesson concludes with the explanation of how the elements of two-dimensional arrays are arranged in memory, followed by a quick discussion on the application of pointer arithmetic and dereferencing operations over base address of a two-dimensional array. Let us start with setting the context and understanding how two-dimensional arrays can be visualized. Modeling of some problems in two dimensions appears to be very natural. For example, images can be modeled as a two-dimensional matrix of its pixel values. Terrains of most of the arcade-based games have a natural two-dimensional arrangement. Handling of data related to such problem statements become very intuitive if represented as two-dimensional matrices or arrays. This is the reason that every programming language has provision of two-dimensional arrays in some or the other way. This sets the context for using two-dimensional arrays. In the coming few minutes, we will understand the conceptual representation of two-dimensional arrays. The lesson on one-dimensional arrays suggested that they can be compared with a chain of boxes, which can hold values of the same type. Extending the same analogy, a two-dimensional array can be visualized as a two-dimensional collection of boxes, which is capable of holding values of the same type. This diagram is a conceptual representation of a two-dimensional array. This two-dimensional array has 5 rows and 4 columns. Since two-dimensional arrays span in 2 dimensions, so in order to uniquely locate an element in this arrangement, we need 2 indices. The row index indicates the position of the row to which the element belongs, whereas the column index indicates the position of the column to which the element belongs. For example, the element in the first row and second column, whose row index is 0 and column index is 1, is 40. The element in the second row and first column, whose row index is 1 and column index is 0, is 43. And the element in the fifth row and fourth column, whose row index is 4 and column index is 3, is 59. We will discuss the process of accessing elements of a two-dimensional array in a little while.